Imagine listening to your favorite song, not from your phone or the cloud, but from data stored inside your own body. Picture a world where your playlist, your memories, and your most treasured moments are literally a part of you, seamlessly accessible at any time, no matter where you are. Every photo, every memory carried within you, not on a device you could lose, but as part of your very being. Imagine never worrying about losing your phone or forgetting a password. Your memories are as close as your heartbeat, woven into your biology. This isn't just science fiction. Scientists are exploring ways to merge our biology with technology, using our bodies as the ultimate storage device. The boundaries between digital and biological are blurring, opening up possibilities we once only dreamed of. The key? DNA, the molecule that already stores the blueprint for life. It's nature's most efficient storage system, perfected over billions of years. DNA is nature's hard drive, and now researchers are asking, if it can store the code for a human, could it also store your digital life? The answer could revolutionize how we think about data forever. Imagine encoding a symphony, a novel, or your entire photo library into your DNA. Your creative works, your memories, and your identity could be preserved for generations, passed down as easily as eye color or a family trait. This could change how we think about information, memory, and even what it means to be human. The line between technology and biology could disappear, transforming our relationship with data and ourselves. Today, we'll explore how data storage works now, how nature does it, and what happens if our blood becomes our personal hard drive. The implications reach far beyond convenience. They touch on privacy, identity, and the very fabric of our lives. This isn't just about convenience, it's about the future of technology and humanity. The choices we make today could shape how we live, remember, and connect tomorrow. Let's dive into the science of DNA data storage. We'll uncover how this technology works and what it could mean for our future. What if your personal history was written not just in photo albums, but in your very cells? The possibilities are staggering, and the journey is just beginning. Let's get started. Right now, your digital world lives on physical devices, hard drives, solid-state drives, and the cloud. Every photo, message, and document you create is stored somewhere on these machines, whether in your pocket or in a distant server farm. Hard drives use spinning platters and magnetic heads to store binary code, ones and zeros. This technology has been around for decades, and while it's reliable, it's also mechanical, with moving parts that can break down over time. Solid-state drives use billions of tiny transistors, making them faster and more durable, but they still wear out over time. Even though they have no moving parts, the memory cells degrade with each write and erase cycle, limiting their lifespan. The cloud? It's just a network of massive data centers filled with these same devices, consuming huge amounts of energy. These centers run 24/7, keeping your data accessible, but at a significant environmental and financial cost. All these methods take up space, use lots of power, and eventually fail. As devices age, they need to be replaced, creating electronic waste and adding to the challenge of managing our digital footprint. We're creating more data than ever, and our current storage tech can't keep up. From streaming videos to social media, the amount of information we generate is exploding, outpacing the capacity and longevity of traditional storage. That's why scientists are looking for something denser, more durable, and more efficient. The search is on for a revolutionary solution that can store vast amounts of data in a tiny space and last for centuries. Nature already solved this problem billions of years ago. Life itself has been storing information in a remarkably compact and resilient way since the dawn of time. DNA is the ultimate storage medium, compact, stable, and incredibly efficient. Just a few grams of DNA could theoretically hold all the world's digital data. What if we could harness that power for our digital lives? Imagine storing your entire digital history in a droplet smaller than a pinhead. The next step in data storage might be inside us. Scientists are already experimenting with encoding digital files into DNA, opening up a new frontier for information technology. Let's see how DNA holds the key. The secrets of the future may be hidden in the very code of life itself. The future of storage could be biological, transforming how we think about preserving our digital world for generations to come. DNA is the original information storage system, perfected by nature. It's inside almost every cell, holding the instructions to build and run your body. DNA's code uses 4 chemical bases, A, C, G, and T, arranged in sequences that store vast amounts of information. A single gram of DNA can theoretically hold over 200 million gigabytes of data. That's more than thousands of top smartphones combined, in a speck you can barely see. DNA is also incredibly stable. Scientists have read DNA from fossils thousands of years old. It's denser and more durable than any hard drive. As our digital data explodes, DNA offers a blueprint for the next generation of storage. The challenge: learning to write and read our digital files in DNA's language. Let's see how scientists are making this a reality. How do we store digital files in DNA? It sounds like something out of a sci-fi movie, but it's quickly becoming reality thanks to advances in biotechnology. First, we translate binary code, those familiar ones and zeros that make up all digital information, into DNA's 4-letter code made up of A, C, G, and T. Specialized algorithms assign unique combinations of zeros and ones to each of the 4 DNA bases, creating a direct link between digital data and genetic code. Scientists then use advanced DNA synthesizers to build custom strands, encoding digital data as precise sequences of DNA molecules. The result is synthetic DNA that stores your file, preserved as a tiny powder, so small, yet capable of holding massive amounts of information. To retrieve the data, a DNA sequencer reads the genetic sequence, and a computer translates it back into binary, reconstructing the original file. This process has already worked. Researchers have successfully stored films, books, and even entire operating systems in DNA molecules. It's slow and expensive now, requiring specialized equipment and expertise. But the proof of concept is here, and the technology is advancing rapidly. We can now write and read digital data in DNA, opening up new possibilities for data storage. The future could mean archiving the world's information in a format that could last for thousands, even millions of years. DNA storage is no longer science fiction. It's a glimpse into the next era of information preservation. Now imagine storing data not just in lab-made DNA, but in your own blood. White blood cells already carry your genetic code. What if we could encode digital files into them? Advanced nanotechnology could edit non-essential DNA, turning your body into a living archive. Your medical history, photos, even passwords could be stored within you, accessible with a simple blood test. Lose your phone? No problem. Your memories are safe inside you. Your body becomes the ultimate secure storage, self-replicating as your cells divide. This is the most personal, permanent data storage imaginable. The benefits of biological data storage are huge: permanence, reliability, and ultimate convenience. Your data would last as long as you do, immune to device failures or cloud outages. Medical emergencies could be safer. Paramedics could instantly access your health info. Vast libraries could be stored in a tiny, energy-efficient format. But the risks are just as real. Editing DNA could have unknown health effects, autoimmune issues, even cancer. Privacy is a major concern. A blood sample could reveal everything about you. Who owns your biological data? Can it be erased or inherited? Could a virus corrupt your DNA, or could governments demand access? The ethical questions are profound. With great promise comes great responsibility. We're blurring the line between biology and technology, fusing our bodies and minds with the digital world in ways we never imagined. Storing data in our blood is the ultimate merger. Technology becomes part of us, not just a tool, but something woven into our very being. This shift forces us to ask, are we truly enhancing humanity, or are we slowly replacing what makes us human with something else entirely? We could cure diseases and preserve knowledge for generations, but we also risk creating new inequalities and opening the door to constant surveillance. The technology itself is neutral. How we choose to use it will ultimately define our future and the legacy we leave behind. We must proceed with caution and wisdom, always questioning the impact of each new innovation. As we integrate technology deeper into our lives, we must ask ourselves, where do we draw the line between progress and preservation? The answer to that question will shape what it truly means to be human in the future.